Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about a specific problem where you have a permutation problem in the case of objects are not distinct. Okay, so this is what we're going to talk about in this video. Well, all the previous examples, all the previous videos, they have one thing in common where you have n objects and you select r objects where the permutations can be formed on all objects being distinctively different from each other. For example, choose 2 balls out of 10 different colored balls. So you can see that the balls here are different because they have 10 different colors. So you can clearly differentiate all the balls given there. Now, if objects are not distinct, that means they don't look different, okay, from each other. So if objects are not distinct, you cannot use the permutation formula which you have seen in the previous example. So for example, you cannot use this permutation formula. Okay, well, so here is an example of such where the objects given here cannot be differentiated from each other. For example, in this question here, we have a total of 3 novels. Okay, we have n equals to 3. The number of objects is actually 3. We have 3 novels. One novel is different from the other 2 copies. So here we've got 2 objects that are not distinctive. They are the same. Okay, so the question is asking you to find how many ways of arranging one novel with different title and 2 novels of the same title, basically. Yes. Now perhaps one way of doing this, okay, because this is quite a simple problem, we only have 3 objects to arrange. Now we can assume that for example, in order to start our discussion, maybe we can assume that they are all distinctive objects. We can assume that they are different. Okay, so it makes it easier. So maybe this one is called A, and this is B1, and this is B2. So by doing this, we are giving them some sort of differentiation. Yeah, so we assume that we have 3 distinct objects, and we have learned in the previous video that if you have 3 distinct objects, then you can arrange them in n factorial ways, which is, in this case, is equal to 3 factorial, and this is going to be equal to 6 different arrangements. Now let us try and have that sort of arrangement in display. Okay, so first we can clearly see that I can rearrange that as B1, B2, and then A going to switch the place, B2, B1. Next I can have A in the middle, so perhaps B1 and B2 is over here, and then we can switch the place, so B2, B1. Next A can be put at the end. We have B1, B2, A at the end, and we switch B2, B1. So total number of arrangements when we assume them all to be distinctive is going to be 6 ways. Okay. Now in reality, what we have here is something that is not distinctive, because really what we have here is the same title. They are actually the same title. And what if we erase the subscript here? So now we're going to erase the subscript. Okay, and I hope you can see that by doing that we will have this one is this becomes the same arrangement. So we have one arrangement. Okay, they are actually similar, and this one is also another different arrangement. So this is another arrangement. Okay, and finally this one here is also another different arrangement. Therefore you can see that from six ways it has been reduced to only three ways. Yes. So when you have objects that are not distinct, then in some ways you will expect that the number of arrangement is going to be reduced, as opposed to assuming them to be distinctive altogether. Okay, so for example 1.9, the answer is going to be three ways. If you have one novel and two copies of the same novel, so actually the number of arrangement is just going to be three ways of arranging these books on the shelf. Let us try and perhaps explore a slightly complicated problem. Let's say you have 4 books and then you have 2 copies of the same title. Let's say 2 copies of A and another 2 copies of B. Okay, now let's start our discussion by assuming that there are distinctive objects. Let's say we're going to call this A1 and A2, B1 and B2. Now let us try to rearrange those books, yeah? And we have learned that if you have 4 distinctive objects, you have 4 different objects, then the number of ways to arrange them is going to be n factorial, and in this case it is going to be 4 factorial, and 4 factorial is just going to be 4, 3, 2, 1, so it's about 24 ways of arranging it, and we can come up with that arrangement pretty easily. Let us try and do this together. Okay, let's say we have A1, A2, B1, B2, and then I'm going to switch this position, so we're going to maintain A1 and A2, B2, and B1 is going to be over here. Next, I'm going to move this position, okay, to this one right here. So I'm going to have A1, A2 is going to be right here, B1 and B2. Next, I'm going to switch position for this one. So we have A1, B2, A2, B1. Okay. Now I'm going to move the position of A2 to the end. So A1, A2, B1, B2. And this one, I'm going to just switch B2 and B1. So A1, B2, B1, A2. So, so far that's what we've got over there. Now, what if I switch so far what we have done is we switch the position of B1 and B2. This is what we've done. Okay, and we have never actually considering switching the position of A1 and A2. So now I'm going to consider this arrangement, but I'm going to switch the position of A1 and A2 in order to get a different arrangement. Yes, so next is A1 and A2 will be switched the position. B1 and B2 is going to be maintained. So what I have here is A2, A1, B1 and B2. Next I have A2, A1, B2 and B1. Okay, this is like, you can consider this as an exercise of systematically trying to rearrange all the objects. Yeah, here we've got A2, B1, and this one is A1, B2. Next, switch this position. So we've got A2, B2, A1, B1. And here we've got A2, B1, B2, and A1. And this is A2, B2, B1, and A1. So that's what I did. Now, what else that we can do? So okay, so what happened here is I have switched this position with respect to this one. Yeah, okay, so now let us try and change the position of A1 and A2 and put it in the middle. Okay, so put it in the middle. So here I have B1. Now I'm going to put A1 and A2 in the middle. Okay, now switch the position of B1 and B2. So B2, A1, A2, B1. Next, I'm going to move A2 to the end. So I have B1, A1, B2, and A2. And I'm going to switch this. So we have B2, A1, B1, A2. Okay, I think that's all that I can do. Now I'm going to move the position of A1 and A2 both at the end. So I have B1, B2, A1, and A2. And I'm going to switch this position, B2, B1, A1 and A2. I'm just switching this with this. Yes, okay. So bear in mind that again, what I have done is I have switched from B1 and B2 with B2 and B1. So this is what I've been doing, B1, B2, B2, B1. So switch that position, but I haven't considered switching this position, switching these positions or this position. So this one is maintained. So in the next arrangement, that's what I'm going to do. I'm going to switch this, so it becomes B1, A2, A1, B2. I'm focusing on switching A1 and A2. Maintain B2, B1. So maintain the position of Bs, but switching the position of As. Okay, so here I've got B2, A2, A1, B1, B1, A2, B2, A1, B2, A2, B1, A1. Okay, next B1, B2, A2, A1, and B2, B1, A2, A1. So you can see that we've got 24 ways of arranging objects that we assume to be distinctive. Okay, Now, I hope you can see that if we assume the objects to be of the same thing, for example, if we assume that uh, two copies of B is B1 and B2 actually the same title, so we're going to get rid of the subscript here. So if you get rid of the subscript here, you will see that so we get rid of it, get rid and get rid. Okay, so going to get rid of it, just focusing on B now. Okay, so we get rid of this, get rid. Okay, this is going to be a good exercise for all of us actually. Okay, so when we get rid of it, we can see clearly that these two here gives the same arrangement. This one also gives the same arrangement. Okay, they are similar actually. So this is actually one arrangement. This is also another one arrangement. They are not different. And this one is also another arrangement. Okay. And this one is the fourth arrangement. This one is the fifth. This is also the same arrangement. Okay. And this is another similar arrangement. Okay, you can see clearly. All right, so this is A2, A1, A2, A1. So we go got B and B on this side. Yes. So so by removing the subscript for B, we have reduced 24 ways to 12 ways. 12 ways of arranging what we consider here two different objects with two similar objects here. Now, what happens if we remove another subscript? We are going to remove this one and this one. Okay, so let's see if we remove that one. Now, I'm just going to erase subscripts for A. Okay, I'm removing it all. Oh, sorry. Okay. Just have to be patient in doing this. Okay. Now you can see by doing that, okay, by doing that, this whole group here is actually have the same arrangement, and so this is actually only one arrangement for that one. Yes, and similar to this one here, we've got the whole thing here. They become similar in terms of arrangement, so that is another arrangement. Okay, here we've got this one over there, this one. So this is the third arrangement. This one is also a similar arrangement when you remove the subscripts for A and B. Okay, and this one is another arrangement. Finally, this is the last different arrangement possible. Okay, and you can see that now we have removed we have reduced the number of ways from 24 to 12, and now it is down to six ways. Okay, so you can see that the number of ways has been greatly reduced if you consider for example, if you consider them to be distinctive, and it has been greatly reduced to 6 ways. So 6 ways is the answer to this question of arranging 4 books where you have 2 copies of A and 2 copies of B. And how do we get 6 ways without going through the hustle of arranging all this one by one? So there is a formula for doing that, and the formula here is very simple. It is n factorial over n1 factorial over n2 factorial over nk factorial. So here n1 here refers to how many similar objects that you have in category 1. N2 here is how many similar objects that you have in category 2. So if you have up to k categories, therefore nk here is the number of objects in category k. So in this example, our n here is 4 books. So here we've got 4 factorial, and these 4 books have 2 categories. So the first one is category A and category B. So these are different categories of books. And for category A, there are 2 copies of this book. So n1 is going to be 2 factorial. And for the second category, which is for this book, we have 2 copies as well. So we have 2 factorial. Okay, so here 4, 2 plus 2 must be equal to 4 as well. So that's basically to make sure that you don't miss out on anything. And this becomes 4 times 3 times 2 times 1 for factorial, which is basically this idea when you start considering them to be distinctive at first, and then you divide them by 2 factorial. So 2 factorial for this one. So this is 2 factorial is 2, and another one is 2. So 2 and 2 here refers to the number of permutation that you can do for the first group, and the number of permutation that you can do in the second group. And because of that, you can see that from 24 ways at the top of this fraction here, so we've got 24, you divide it by 4, and you will get the answer is equal to 6 ways. So the same thing for this one here. The formula, like I said just now, is n factorial over n1 factorial, n2 factorial, blah blah blah, nk factorial. And in this case, we have 3 books, so 3 factorial, and we have category A and category B. We have 1 novel with a different title and 2 novels with another title. So here the number of copies is 1, so 1 factorial, and this one is the number of copies for category B is 2 factorial. So here we've got 3 times 2 times 1 over 1 times times 2. Okay, 2 factorial is 2. So I hope you can see that 3, 2 and 1 here refers to the first part of exercise that I've done here by assuming that they are distinctive objects. If we assume them to be distinctive objects, then we get 6 different ways of arranging them. But then after you erase the subscripts, so remember you've got all the subscripts here, after you erase it, then the number of ways is reduced to 3 arrangement. And how do you get this 3 arrangement is by considering dividing the result here with the number of permutation for that object. Okay, now let us try and do this example here. So we have a mini library that has 5 copies of The Kite Runner, so this is category 1. 7 copies of Crazy Rich Asians, so this is category 2. 3 copies of In Order to Live, this is category 3. And a copy of My Life in a Harem, so this is category 4. So how many ways can all the books be arranged? So again, we're just going to follow the formula, which is n factorial. We've got n1 factorial, n2 factorial, n3 factorial until the end of the category, which is nk factorial. Now, how many number of objects that we have? So we have 5 plus 7, 12 plus 3, 15. And a copy, which is 1, so 16 factorial. So here we've got 16 factorial. And then we've got different categories. So for the first book, the category here, we've got 5 copies. So here we've got 5 factorial for the first book, 7 factorial for the second book, 3 factorial for that one, and 1 factorial for this last category. And I'm sure you'll be able to get that the answer to this question is going to be 5765, 760 different ways of arranging the books on a shelf. Okay, thank you very much for watching. That's all for now. See you again in the next video.